Hello pre-calc students, going through the entirety of midterm prep sheet 2. So f of x is equal to 4x plus 2, g of x is equal to 3 over x minus 5. We need to find f of g of x, or as this can also be viewed as f circle g of x, means the same thing. And what our goal is to plug g of x into f of x. So 3 over x minus 5 becomes the input into f of x. So we have 4 times 3 over x minus 5 plus 2. So 4 times 3 over x minus 5 plus 2, this becomes 4 over 1 times 3 over x minus 5 plus 2, so this becomes 12 over x minus 5 plus 2. Multiply the 2 by an x minus 5 over x minus 5. And you get, and by the way, the reason why I'm multiplying is because I want to get a common denominator. When I add fractions, I have to get a common denominator once I start simplifying. So I get 2 times x is 2x, 2 times negative 5 is negative 10. So you get 12 over x minus 5 plus 2x minus 10 over x minus 5. So I have to multiply by x minus 5 to get a common denominator. You need to have an x minus 5 as the numerator to make sure I'm multiplying by 1 so I don't change the value of 2 in this term. Because multiplying by 1 doesn't actually change its value. Anything divided by itself is 1. So in order to add across fractions, I have a common denominator. So I'm going to write this as 2x negative 10 plus 12 is plus 2. 2x plus 2 over x minus 5. That is our solution. So this is f of g of x, and this is in pretty much as simplified as we're going to get it. This is f of g of x. Factoring out a 2 here doesn't really accomplish anything. All right, so that's the first problem in sheet 2. Let's go to the second problem. The polynomial function has 0 at 1, so our 0 is 1, x equals 1, multiplicity 2, sorry, multiplicity 3, multiplicity 3, a 0 at 2, x equals 2, multiplicity 4, 0 at negative 2, multiplicity 1, a 0 at negative 5, multiplicity 2. Okay, so now we have x. If our 0 is 1, our factor is x minus 1. For multiplicity is 3, x minus 1 cubed. If our 0 is 2, our factor is x minus 2, multiplicity 4. If our 0 is negative 2, our factor is x plus 2, multiplicity 1 leaves 1 power. If our 0 is negative 5, our factor is x plus 5, multiplicity 2 squared. All right, so this is the polynomial in factored form. So this is the polynomial in factored form. And this is the simplest version of this polynomial in factored form. All right, so our steps are for this problem, you write 1, we have to graph in Desmos. 2, graph our answer choices in Desmos. Graph answer choices in Desmos. and then 3, whichever answer choice matches the original graph is the solution. So once you get this polynomial factored form, you just have to take your answer choices in expanded form and find the solution, just because that's going to be faster than expanding all of this out. Okay. F of x is equal to the square root of 12 minus x, k squared minus 6k. This is when x is equal to less than negative 37. This is when x is greater than or equal to negative 37. What value of k makes the piecewise function continuous? We're going to make this piecewise function continuous. We need to set our equations equal to each other at x at the point where the two formulas meet. And these two formulas meet when x is equal to negative 37. So I have the square root of 12 minus x is equal to k squared minus 6k. But this is when x is equal to negative 37. So plugging in negative 37, I have the square root of 12 minus negative 37 is equal to k squared minus 6k. 12 minus negative 37 is 12 plus 37, that is 49. So the square root of 49 is equal to k squared minus 6k. I will have square root of 49 is 7. 7 is equal to k squared minus 6k. And so, because 7 is equal to k squared minus 6k, k squared minus 6k minus 7 is equal to 0. Factoring out k squared minus 6k plus 7, this will factor to k minus 7, k plus 1. And this is because negative 7 plus 1 is negative 6. Negative 7 times 1 is negative 7. So if k minus 7 equals 0, k is equal to 7, that is one solution. And if k plus 1 is equal to 0, k is equal to negative 1. That is your second solution. So our two solutions are 7 and negative 1. Moving on. Alright, so this problem I've already kind of done and annotated. So the main work that you have to do is rewriting this equation. So I want you to look at negative 1/4 times the square root of 4 minus 2x plus 1. I think it's just much easier to understand if you have your variable come first. So you can rewrite that as negative 1/4 times the square root of negative 2x plus 4 plus 1, which now, this is the very important part. You must factor. You have to factor. Negative 1/4 times the square root of negative 2 factored out. Negative 2 is factored out. Negative 2x divided by negative 2 is x. 4 divided by negative 2 is negative 2, all plus 1. And that's how I got negative 1/4 times the square root of negative 2 factored out of x minus 2 in parentheses plus 1. This is up 1, right 2, horizontal compression by 1/2, a y-axis reflection, a vertical compression by 1/4, and an x-axis reflection. So that's our solution. One thing that you should just know is that vertical compression is what you think. Vertical movement, it's outside of the function. So multiply by 1/4, you shrink it by 1/4. Outside the function, plus 1, it moves up 1. But x minus 2 inside the function, it's horizontal, and it does the opposite of what you think. Minus 2 right through 2. You think you'd be multiplying by 2, but actually this is a horizontal compression. You're multiplying by 1 over 2, which is a horizontal compression, by 1/2. All right. So this is one of the biggest problems that we'll have to be able to do in the test. So I'm going to start this from scratch. If we wanted to do this problem, I want to teach you a shortcut method for when you have answer choices. So I am going to provide answer choices for this problem. All right. Answer choice A is going to be x plus 1 squared x minus 3i x plus 3i. Answer choice B will be x plus 1 squared x plus 3 x minus 3. Answer choice C will be x plus 1 squared x minus I x plus I. And answer choice D will be x minus 1 squared times x plus 4i x minus 4i. Now, regardless of whether we're doing the multiple choice trick or not, our first step is to take our original function and graph this in Desmos. And what do we see when we graph this in Desmos? We have x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. And we see we have a parabolic shape at -1, 0. So when we graph this in Desmos, at the x-axis we have a parabolic shape, and we intercept the axis at -1, 0. So we intercept the axis at -1, 0. Now this, when we hit this 0 bounces, all right? So this 0, it hits, the graph hits the 0, but instead of passing through the x-axis, it bounces back. That's an even multiplicity. And it's also in the shape of a parabola. So because it's in the shape of a parabola, that even multiplicity is probably, in fact, we know because it's in the shape of the parabola, multiplicity 2. Multiplicity, oh sorry, that, my pad kind of sketched out there. Multiplicity 2. Multiplicity 2, okay? So if our 0 is -1, our factor is x plus 1, and our multiplicity 2 is x plus 1 squared. All right, so we know, now that this is 0, that x plus 1 squared is a factor. So this is a factor. And because x plus 1 squared is a factor, we can actually eliminate from this answer choice D. And the reason why we can eliminate answer choice D is is because x plus 1 squared must be included in the factored form of the polynomial. So this has to be included. This must be in an answer. Must be an answer. Once we figure out it's a factor, we know this must be in our answer because we're trying to find the function in factored form. Now, the way to now solve this is we have to, the trick to do with multiple choice questions, you can just plug in these factored forms and see if they match up with the polynomial. So we can plug in b right away. B doesn't have imaginary numbers. Let's try plugging in x plus 1 squared, x plus 3, x minus 3. So we can go to Desmos and plug in x plus 1 squared, x plus 3, x minus 3. And we can see this green graph does not perfectly match up with this problem. And because of that, because this green graph does not match up, we can eliminate answer choice B because it would have to match up perfectly. So I'm going to eliminate answer choice B because it doesn't match up when we graph it. This doesn't match. Now let's look at multiple answer choice A. In order to make answer choice A match, we need to be able to graph in Desmos in the first place. But we need to expand by multiplying our complex numbers first before we can graph it. X plus 1 squared, you leave that the way it is. But x minus 3i, x plus 3i, we have to expand this. X times x is x squared. X times 3i is plus 3ix. Negative 3i times x is minus 3ix. And negative 3 times 3 is negative 9. And I times I is I squared. As a friendly note, I is equal to the square root of negative 1. I squared is equal to the square root of negative 1 squared, which is equal to negative 1. So negative 9i squared is equal to negative 9 times negative 1, which is equal to positive 9. So when we simplify this, negative 3ix and positive 3ix cancel out. So we just have, if negative 9i squared is just 9, this becomes x squared plus 9. So now this becomes in factored form x plus 1 squared times x squared plus 9. And x plus 1 squared times x squared plus 9 will match up with our original graph perfectly. So we know the answer choice is A. So if you have multiple choice answers, this matches with x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. So x plus 1 squared times x, this matches. So that means this is our solution. Now I do also want to go over how you would find this without multiple choice. So the answer choice is A, but here's how you get this without multiple choice. When you use polynomial division, so if we have x plus 1 squared, we can do polynomial long division. Or we can just divide by x plus 1 over again. So if we want to do x to the 4th, sorry, x to the 4th plus 2x cubed plus 10x squared plus 18x plus 9. Because x plus 1 squared is a factor, that's a factor, right? And x plus 1 squared becomes x squared plus 2x plus 1. We can divide by a factor to have a clean remainder of divide by x plus 1. Sorry, x. It's not the highest production quality, that's okay. We divide by x squared plus 2x plus 1. Sorry, now my computer's freezing up, but hopefully it will not freeze up in just a second. I just need to have space over my quotient. So I'm going to start polynomial long division now. X squared times x squared is x to the fourth. So x to the fourth, x squared times 2x is 2x cubed plus 2x cubed. And then x squared times 1 is 1x squared. Polynomial long division, group, subtract, cancels out, 10x squared minus x squared is 9x squared plus 18x plus 9. Alright, and then x squared plus 9 times x squared is 9x squared. 9 times 2x is 18x. And 9 times 1 is 9, so this will, parentheses, subtract, cancels out perfectly. So our quotient is, our remainder is x squared plus 9. So after dividing our original term by what we know is a factor, we're left over with x squared plus 9. And I'm going to rewrite this as x squared plus 0x plus 9. So a is 1, b is 0, c is 9, and we find our other factors in the answer choice by the quadratic formula. Negative b plus or minus the square root of b squared minus 4ac all over 2a. So that's negative 0 plus or minus the square root of 0 squared minus 4 times 1 times 9 all over 2a. So that's all over 2. So that's equal to plus or minus the square root, 9 times 4 is 36, of negative 36 all over 2. And so the square, so just by a heads up, square root of negative 36 is equal to the square root of negative 1 times 36, which is equal to the square root of negative 1 times the square root of 36, which is equal to, next square root of negative 1 is I times 6, square root of 36 is 6. This is equal to 6i over 2, plus or minus, of course. This is equal to plus or minus 6 over 2 is 3i. So for when you have other zeros of plus or minus 3i, then your other factors are x plus 3i x minus 3i, and of course we have that factor of x, x plus 1 squared. That's how we get this solution without multiple choice. Find the inverse of 500 over 7x plus 3. Is the original function 1 to 1? So to find the inverse, first we have y is equal to 500 over 7x plus 3. With inverses, we switch the y's and the x. X is equal to 500 over 7y plus 3. Multiply each side by 7y plus 3. Multiply this by 7y plus 3. 7y plus 3 times x is 7xy plus 3x is equal to 7y plus 3's cancel out, 500. So if 7xy plus 3x equals 500, I need to make sure my y term is by itself. So I'm going to subtract 3x from each side. 7xy is equal to 500 minus 3x. Now, in order to isolate y, because that's my goal here, I need to divide each side by 7x. The 7x's cancel out, and now that y is isolated, I can write in inverse notation. The inverse of f of x is equal to 500 minus 3x over 7x. Now we need to ask, is the original function 1 to 1? We'll do 500 over 7x plus 3. (500 over 7x plus 3). It's a rational function. A horizontal line will never intersect this graph twice. So, just looking at the problem, 500 over 7x plus 3. It is a rational function. Alright, this horizontal line will never intersect this function more than one time. So this passes the horizontal line test. A function passes the horizontal line test. It is 1 to 1. Alright, determine the symmetry, odd, even, neither, of f of x equals the absolute value of 30x. G of p is equal to 10p over p squared plus 4. H of t is equal to negative 4t cubed minus 8t plus 5. And y is equal to x squared. Now, as a definition, even functions you have the algebraic rule f of negative x is equal to f of x, and you are symmetric about the y-axis. And with odd functions, you have the algebraic rule f of negative x is equal to negative f of x. And you are symmetric about the origin. Remember, the origin is the point 0, 0. So I'm going to show an example of the inputs and outputs, and they really easily tell me whether a function is even or odd. So the absolute value of 30x. The absolute value of 30x. Now I can see that this function is symmetric about the y-axis, but furthermore, let's look at the table. Negative 260, negative 130. 130, 260. So if regardless of my input's negative or positive, as long as it has the same in absolute terms, the output's the same. That's what it means when this function is even. So this is an even function. Alright, I have input negative 260, 260. Negative 130, positive 130. So that means this is an even function. And plus we have that y-axis symmetry. G of p is equal to 10p over p squared plus 4. Excuse me. All right, so see this function right here? We see we're symmetric about the origin, so we know it's odd. But even furthermore, look at these inputs. -2, negative 2.5. 2, positive 2.5. -1, negative 2. 1, positive 2. This is true for all numbers. This is true for all numbers. So you can even check this would be true for -3 and positive 3. So going back to -2, negative 2.5. 2, positive 2.5. 1, negative 2. Positive 1, positive 2. That is the example of an odd function. So this function is ODD, odd. All right. H of t is equal to negative 4t cubed minus 8t plus 5. Negative 4x cubed plus 8x plus 5. Minus 8x. All right, this function clearly has no symmetry, so I can immediately tell that it is neither. It's neither if it's not even or odd. That means it has no symmetry. So neither. Looking at the tables, -2, 29, 2, -19. -2, 29, 2, -19. And immediately, as soon as you find one example where you have inputs, outputs don't have the same absolute value, then it's not even or odd. And y is equal to x squared. This is even, symmetric about the y-axis. -2, 4, 2, 4, -1, 1, 1, 1. So this is an even function. So even, odd, neither, even. 9x cubed plus 6x squared plus 12x plus 16 times 3x minus 1 to the -1. So the hint here is that this is 3x minus 1 to the -1. That is equal to 1 over 3x minus 1 to the positive 1. So this, rewriting this, becomes 9x cubed plus 6x squared plus 12x plus 16 all over 3x minus 1. And this is where we do some polynomial long division. 9x cubed plus 6x squared plus 12x plus 16 divided by 3x minus 1 9x cubed divided by 3x is going to be 3x squared. So in the x squared, I write 3x squared. 3x squared times 3x is 9x cubed. And 3x squared times -1 is minus 3x squared. I group in parentheses and I subtract. 9x cubed minus 9x cubed is 0. That cancels out. 6x squared minus -3x squared is 6x squared plus 3x squared, which is 9x squared, bring everything else down, plus 12x plus 16. Now, I multiply, once again, leading term dividend, leading term divisor. 9x squared over 3x is equal to 3x, so 3x squared plus 3x 3x times 3x is 9x squared, and 3x times negative 1 is minus 3x. Group, subtract. 9x squared minus 9x squared is 0. 12x minus negative 3x is going to be 12x plus 3x, which is 15x plus 16. And now my last term is going to be, I need a term that cancels out with 15x, so 3x times what equals 15x? 15x divided by 3x. X's cancel out. 15 divided by 3 is 5. 3x squared plus 3x plus 5. 5 times 3x is 15x. 5 times negative 1 is negative 5. Group, in parentheses, subtract 15x minus 15x is 0. 11 minus negative 5 is 11. Sorry. My bad handwriting almost gave us the wrong answer. 16 minus negative 5 is 16 plus 5, which is 21. So 3x squared plus 3x plus 5, this is our quotient. And 21 is our remainder. So we have 3x squared plus 3x plus 5 plus 21 over 3x minus 1. Okay. So I already have some work here. I'll erase it so I can do it from scratch. Alright, so create a function with zeros. Zeros of x equals 0, multiplicity of 2. So for 0 is x equals 0, our factor is x, multiplicity of 2 squared. For 0 is x equals 3i. Then we have our factor is x minus 3i. For 0 is x equals negative 3i. And our factor is x plus 3i. For 0 is negative 1. Our factor is x plus 1. Okay? So it needs to have, these are our factors, these are our zeros. It needs to have the end behavior of negative x cubed. Negative x cubed looks like this. You should know this from memory. This has the end behavior as x approaches negative infinity, y approaches infinity. As x approaches infinity, y approaches infinity. Another thing we know is that the reason why we know this is because this is a polynomial. This is the end behavior of a polynomial with a negative leading coefficient and an odd degree. So we have a negative leading coefficient and an odd degree. So if x squared times x plus 1 becomes x cubed plus x squared, and x times, and now we multiply x times x. This becomes x squared, x times 3i plus 3ix, negative 3i times x minus 3ix, negative 3i times positive 3i. Negative 3 times positive 3, that's minus 9. I times I is I squared. I squared is negative 1, so negative 9 times negative 1 is positive 9. 3ix and negative 3ix cancel out. So we have x squared minus, actually, plus 9. So we have x squared plus 9 times x cubed times x squared. And this creates x cubed times x squared, that's x to the 5th. X cubed times 9 is plus 9x cubed. X squared times x squared, that's plus 4x squared. X squared plus 9 is plus 9x squared. X to the 5th plus 4x squared plus 9x cubed plus 9x squared. This is equal, right, to taking our function factored form and expanding it. Now, the thing about this problem, though, is what we see is that while this has all these zeros and it's in factored form, this does not have the same end behavior as negative x cubed, because we have a positive leading coefficient with an odd degree. So we're going to have a positive leading coefficient, an odd degree. We need to change to a negative leading coefficient, an odd degree. So we need to change from positive leading coefficient to a negative leading coefficient. How do we change that? We can just multiply the term by negative 1. So we multiply this whole polynomial by negative 1. Negative x to the 5th plus 4x squared plus 9x cubed plus 9x squared. This just becomes negative x to the 5th minus 4x squared minus 9x cubed minus 9x squared. And this is a polynomial that has a multiplicity of, it has these zeros of x equals 0 and x equals negative 1, and it has the end behavior of negative x cubed. So this is our solution right here. Find the horizontal asymptotes, vertical asymptotes and holes of 5x squared plus 5 over x squared plus 6x plus 7. So first we have to factor out of 5. Factor to 5, what's left over? X squared plus 1. So we need to factor everything out. And this is, just to make things work easier, I'm going to switch this into a negative 7. This is a negative 7. I can factor this out into x plus 7 x minus 1. And we can see that there are no holes because no factors cancel out. If there were holes, the factors would have to cancel out on the numerator and the denominator. No factors cancel. So no factors cancel. No holes, no factors cancel. So now we just need to find let's find some vertical asymptotes. My vertical asymptotes, I set my factors on the denominator equal to 0. X plus 7 equals 0. X minus 1 equals 0. X is equal to negative 7. X is equal to positive 1. These are my vertical asymptotes. And here I have my horizontal asymptotes. Now, once again, my degree on the bottom is equal to my degree on the top. So my horizontal asymptote here is just going to be the ratio of the leading coefficients. So here the ratio of leading coefficients is 5 leading coefficient of the numerator, over 1 leading coefficient of the denominator. So our horizontal asymptote, because the numerator degree equals our denominator degree, our horizontal asymptote is going to be the ratio of the leading coefficients. That's going to be leading coefficient 5 over leading coefficient 1, which is equal to 5. So our horizontal asymptote is y equals 5. Okay, this is the video. Best of luck on your midterm.